previous live in between because some things came up. Uh, what? Background noise. Sorry. Yeah, sorry. So, my apologies that I left in the previous live because some things came up I had to attend to. So, I completed that in shorts. So I yeah, so that's why I left. Now I'm here again live. Sorry for that. Okay, so let's go. Now we are gonna see complex integral for line, straight line and parabola. Integrate f of z equal to z square from a 1 comma 1 to b 2 comma 4 along unit parabola and a straight line with y equal to t square and x equal to t. So this is parametric equation. Okay. So first things first, we have to find. So we have to first decode the question. So first said integrate, integration sign f of z equal to z square. So we have to integrate f of z, which is z square. So we have to find the means like the main thing which is after the f of z. F of z is a name of the function. We can't solve that. We have to solve the function. So what is in the equal to sign assigned, that we have to take z square. Since it is integration, so we take dz2. Now from that is later part because it is constraints, it is limits, so we have to take it later on. I'm going to show you what it means. So this is x. First we write x in coordinates, then y. So this is x coordinate, this is y coordinate. We would need this later on. 2 b, so b is the end one, end limit. Okay, 2 comma 4. Okay, 2 comma 4 x y. Okay, now by the way, this is not exactly a question in pyq. I clubbed the questions in pyq and reference books to make, so that to make a question so that we can go hardcore nuzlocke mode. So yeah, along unit parabola. So yo, three people, what's up? Thanks for coming, man. So yeah, equation of parabola equal to y square. Since parabola is a quadratic equation, a square term, square curve. So y square equal to 4x plus c. It is okay, and straight line. So let's write the straight line thing too. So that is y equal to mx plus c. This is standard line equation. Since, but the problem is there is no slope, it is straight line. See, m is slope. Okay, tan theta. Okay, tan theta is equal to tan inverse x by y. But there would be no tan because here some angle is there, then theta would come. But this is straight line. Straight line, slope won't be there. So this is out of the picture. Okay. Okay. Now we don't take constants in this integration because there is already constant in integration and we are taking limits. So in limits we don't need constants because we know everything, the numbers we are gonna substitute. And we took unit parabola. Okay, unit parabola. Like then this coefficient 4a would be 1. Okay, so 1 into x square, 1 into x. So yeah, for straight line, there would be no tan 0 equal to, that would be 1. Okay, slope. So now we got most of the things. So let me just make the equation better. Y equal to x square, y square equal to x, y equal to x. So now there is also another thing. Okay, but this we would solve later. Okay, y equal to t square, y equal to t, that parameter thing. Okay, now first things first. First I would solve, I guess, z square, what it would be. Okay, let me see, its camera focus is not there. So yeah, y z square equal to integration z square dz. Okay, so what do we have? Integration z square dz. Then what do we have? Z square. We have to find and dz we have to find. By the way, I should give some space, dz. Okay, since we know, here we would use Cartesian form because it is a line. Okay, this is not a circle that there would be angles. There can be angle, but that won't be the, you know that won't be the, that would be parameter out of the line, not off the line. Okay, so angle made by line, not angle off line, but circle is angle type stuff, a full angle, 2 pi angle, so yeah. So z equal to x plus iy, it in complex integration, in complex numbers, z equal to, first we will write everything minus iy, then there is mod z equal to root x square plus y iy square, that average stuff. Now z square, so I have to substitute, since we are solving everything in x and y, actually in t, by the way. So I have to first we have to solve as x and y, then we can go for t. So z square, so z we have to substitute by this x plus iy, which is the value z equal to x plus iy. So we have to, since z and x plus iy are same thing, so we have to substitute this x plus iy in the z place and take it square. Since x plus iy we are taking, then whole square, which would be, let me show you, a plus b whole square is equal to a square plus b square plus 2ab. So by this formula it would be x square plus 2 into x, a is x, b is iy plus uh, y square, yes, y square, yeah. Now, so this is z square, okay. Now dz would be, wait a second. So z is, first thing, z is x plus iy, right? Wait a second. Let's take dz by dx, okay. So this would be, since this is x plus iy dx. Oh, 2 likes. Thanks for that, man. Thanks. I really appreciate your support. I'm really grateful. Thank you very much for your likes. And 4 people watching, really appreciate it, man. You really make my day. So, we are taking, instead of z, we took this. Now, we have to take dx. So, you have to know that d of f of x plus g of x whole, if we take by dx, it is same as, we can solve it separately, f of x by dx plus d of g of x dx. These are the same thing, so what we would do here is, dx by dx, this would be definitely 1 plus, since, wait a second, I would tell you that later, diy by dx. But since you know that I is a constant, so when we do d of kx by dx, it is same as k into dx by dx, right? Constants are taken out. So we can multiply constants after taking derivative directly, okay? So now it would be, this is 1, okay? Dx by dx is 1. Same thing in numerator, denominator, it is divided, it is 1. Simple thing. Now, but also another thing is that, let me show you. Dx raised to n equal to nx raised to n minus 1. Same thing with integration, x raised to n equal to, you need this, so I'm telling that, x n plus 1 by n plus 1, okay. So now here it would be I dy by dx. Oh, sorry, this would be 1, right? Plus 1. Oh, this one won't vanish, right? So dz by dx is this, okay? Now, mm, let me see. Dy by dx is equal to, okay. Mm, okay. Now we found these out. Now we found z square. Okay. Now we go to first question, which is first question is y square equal to x. We have to find it along y square equal to x. Then we would substitute every y term, every x term with y, because if we take if we do it in x term, it would be y equal to root x. That would be very difficult. But y, if we do it in y term, then it would be easy because y is in square term. Square is easy to calculate than root, you know. So y square, we would do everything in y term. Like we would substitute every place where there is x with y. Okay. So then we should have done it in y form. Okay, that was a problem. Then let's do line one first. Okay, then let's do line. Line is y equal to x. So we can choose any term now. So we would go with x. We would solve this in x terms. So we would, since y and x are same, y is equal to x, then we would put x in every place there is y, so that our solving would be easy because there would be only one variable. Okay. So now let's first take z square. Okay. Z square equal to x square, we found this. Okay, plus 2ixy plus y square. Okay, now what we have to do is, uh, since we have y equal to x, we would substitute here x because y is equal to x. Y and x are same. So we would put x in this y area, it would be still the same. So z square equal to x square plus, and here also x, okay, 2ix square. See, if I put x here, then it would be x into x, which is x square, okay? That's how it happened. So plus x square. Then it would be x square plus x square, same things, same variable type, same raised to variable, x raised to 2, x square. So they can be added. So this is 1x, 1x. So coefficients are added and this stays the same. So 1 plus 1 is 2. See, let me show you. 1 plus 1 into x square. Okay. This goes out in multiplication. Then we add its coefficient, which is 1 plus 1 is 2, and x square. Okay, 2x square. Now we have plus 2ix square. Okay. Oh, wait a second. We actually have here iy square, because I square y square, because it was iy. So iy whole square is I square y square. So now we have, so I square, most people would know I square is equal to minus 1, since I is equal to root minus 1. Okay. So then minus 1 into plus would be minus, because minus into plus is minus. So this is actually okay. So I did a huge mistake here. Okay. So y is equal to x. So this is x square. So but this was minus. This was minus. Let me show you. This was minus. This was minus. Okay. Wait a second. It got blur. Yeah. So this is minus y square. This is minus x square. So this won't be added. This won't be subtracted. See, this is opposite sign, minus plus. These two are opposite signs. They would subtract, not add. So when we subtract them, 1 minus 1 becomes 0. So this is 0x square. So this term actually vanishes. We get this 2ix square. Okay, in z square. Now dz by dx. Okay, now dz by dx is equal to, we found it here, dz by dx equal to this, okay, is 1, so here it is, wait a second, dx, this is the final thing, okay, 1 plus I dy by dx, okay. Since y equal to x, in this place of y I can substitute x, okay, see here, y equal to x, so dz by dx equal to 1 plus I dx by dx, so which is equal to 1 actually, right? Dx by dx is, let me show you, dx by dx, so by this formula, uh, by the way, this is not exactly how we write it, dx raised to n by dx, okay, this became way more messy. Now I have to write here nx raised to n minus 1. Here we go. Now dx by dx would have been x raised to 1. It is like d by dx of x we are taking. So x means x raised to 1. Now nx raised, since derivative of x raised to n is nx raised to n minus 1, then this n would go here. This would be 1x1. Then here nx raised to n minus 1. Then n minus 1, 1 minus 1, which is 0. 0. Anything raised to 0 is 1. So 1 into 1. 1 into 1 is 1. And 1 into anything is that itself. So I into 1 is I. Simple. Now this x goes here. This is in division. This would go here in multiplication, because this can't differentiate. Because this is different variable, z is different variable, x is different variable. So we can't differentiate that. We are just finding what it would be equal to. And we found this, okay. So dz equal to 1 plus I into dx, whole bracket into dx. And this is what we found, okay. But is the question over here? No. Because we had to find in terms of t2. See, here it is. Y equal to t square, x equal to t. But y equal to t square, x equal to t, here we have in x terms. Both in x terms, okay. So we can substitute, since x and t are equal, x equal to t. See, here x equal to t, x and t are same. So we can substitute x by t. It is the same thing. Since x and t are same, so if we substitute in their function, in x function I substitute t, then it is also the same thing. So here we got 2ix square. Since x equal to t, I don't have to substitute anything extra like any function in this. So this would be 2it square, okay. So same I have to substitute here to, it is dx, then I make it dt. So we had function here integration z square dz, and we found what is dz, and we found what is z square. So let's solve it. Simple. Integration 2t square into, wait a second, 2it square, sorry, 2it square into 1 plus I dt into, wait a second, yeah, to 1 plus I dt. Here we go. Now, no, we can't take I common. That's the problem now, you know. But I can do a simple thing. See, this is here. This is going to be multiplied into this whole bracket. So I have to multiply to this and multiply to this. Addition separates terms, and multiplication is the whole thing. So multiplication, when it multiplies to a bracket, it multiplies every term in the bracket. So these are separate term. I have to multiply separately. 2it into this, 2it into this, 2it into 1, 2it into I. Okay. So I have to do integration. Anything multiplied by 1, it stays same. So 2it square into 1, 2it square, plus, and integration also, like let me show you, integration f of x into g of x, sorry, plus g of x is still integration of f of x plus g of x. Separately we can take it out, no issues with that. Okay, we can take out separately. So now plus, wait a second, camera focus is gone, oh my god. Okay, yeah. So now if we multiply this 2it square by I, then I is already present here. I is all second I it is. Oh, 3 likes. Thanks, man. I really appreciate that. Thanks, man. Thank you very much. I'm grateful for your support, man. Thanks. Thank you very much. So in 2it we have I already. Now again there is I. We are multiplying. Then same things, if multiplied 2 times they become square. Okay. 2 into I square t dt. Now you might recall I square was, since here I wrote it, I is equal to root 1, root minus 1, then I square equal to minus 1. Simple. So minus 1 we would take it out, and this would be multiplied to this plus, it would become minus. So integration 2it square minus 2t dt. Wow. Okay, we can take this 2 even common, like we can take this 2 out common. Okay, I told you, right? Okay, I didn't tell that. Okay, integration of k into x is equal to k into integration of x. Like, you have to take this constant out, and you can just multiply the same constant after you have integrated x. It would mean the same thing. Integration into of constant into variable, it is the same thing. So we can take 2 out. Okay, 2 we have taken out from both. 2 here taken out, it square. 2 here taken out, t. Okay, so 2 integration it square minus t. Okay, dt. Okay, now we would do it separately. I guess you can see. Yeah. So by the way, I'm using this space, so it might look messy, but I don't have much space in the board. So yeah. Okay, here we go. Now it square minus t. This is a very problematic question, Now I showed you this integration of x raised to n equal to x raised to n plus 1 by n plus 1. We have to use that formula. So the first, let me write this first, square brackets. Now integration of it square minus integration of t. I told you here integration of f of wait a second. F of x plus g of x equal to f of integration f of x plus integration g of x. So we can integrate them separately in addition subtraction, and just do the same operation like addition subtraction after we have taken the integration. So now what I do is I have to take this. Wait a second. Why there is 1 here? Okay. I can take this constant out because I is constant. Here I told you where it gone. Yes. Integration of kx equal to k integration x. So this I is constant. I can take out this I. Right. Since it is a constant, I can take it out and multiply after everything integration is done. Okay. I integration of t square minus integration of t. Right. Now in derivation this t would have gone away, 1 would have come out, but in integration it is opposite, so it would add the power, it won't reduce the power. Okay, in derivative we reduce the power, in integration we increase the power. Okay, raised to thing. Okay, like how much time it would multiply itself, that would increase. Now t square integration, let's use this formula. Here n is 2, like x raised to n. X had n as its power. Here t raised to 2, t square. So 2 is t's power. Okay. So what it would be, we would add the power and divide that added power. So t raised to 2 plus 1 Okay. Oh, sorry. Did I disconnect? I'm really sorry. Did I disconnect? Oh my, I'm really sorry. Sorry, huh? I'm really sorry. Apologies. Kindly forgive me. I think I disconnected. Sorry, internet issues. Okay. So, integration of x raised to n equal to x raised to n plus 1 by n plus 1. So we add that power, whatever power there is, we add that and we divide that added power. So we have power here 2. We added 1 to that power, 2 plus 1. Then we divide that added power 2 plus 1 here 2. Divide that same added power here below, 2 plus 1, which is 3. 2 plus 1 is 3. So we divide by 3 and here raised to 3. Same we have to do here. uh, T raised to 1 it is, so we have to add 1 here, becomes 2. We have to divide by that added a new power, 1 plus 1, which is 2. Here I divided by 2. Here we get t raised to 2, t square. Now dt. Now there is a bigger problem. Now we have to find constraints. Let me show you. Like we have done the integration, but we have to something put something in these limits, like integration in here we add some limits. Like we are, integration is finding area, but from where to where we are finding area. Like I am finding like which number I have to put. Like from this area I am finding. So it starts from here, ends from here. Then how would I find area? I would find the area of end, then reduce it from area of start. Let me show you. Like I am using this square, I have to find area of this part. Then I would find the area of whole. Then I would reduce the area of this. Then I would get area of this. So yeah, that's what we are gonna do here in integration. We do that by formulas. But wait a second, it became very messy right now. I have to make it Ronaldo. I mean, I have to make it. I have to draw some lines so that it looks kinda organized. Not totally organized, but at least organized. Since we are using t here, these were the limits. Like, see, we are doing it in x term, right? We did everything in x term. We are gonna take x coordinate, which is 1, and ending coordinate is 2. Lower limit, upper limit, okay? 1 is to 2. But it is not that simple. X because here there is parameter x equal to t, so we have also found it in t term, dt, with respect to dt t. So we have to find even coordinates as t terms. So we have to substitute this t in x. So since x equal to t and here x equal to 1, so t equal to 1 in lower coordinate. In upper coordinate x equal to 2, x equal to t, then t equal to 2. Simple, right? Here also, here also. So x equal to t, then x equal to 1, then t also equal to 1. LHS, if LHS is equal to, wait a second. LHS 1 equal to LHS2, LHS1 equal to LHS2, then RHS1 equal to RHS2. If two equations are there, LHS1 equal to RHS1 and LHS2 equal to RHS2, right? It is like common symmetry, right? If 3 is equal to 3 and 2 plus 1 equal to 3, 2 plus 1 equal to 3, here let's say 4 minus 1 equal to 3 and 2 plus 1 equal to 3, RHS are same, then LHS is also same. 4 minus 1 is equal to 2 minus 1 too, na? Because minus is opposite. Minus is opposite of plus, and 4 is just double of 2. So that opposite thing covered it, right? Minus 1 plus 1, here this minus 1, it would come here in opposite POV, it would be plus 1, then 1 plus 1 would be 2, 2 plus 2 would be 4, so it became equal, no? So that's how it works, okay? Since LHS equal to LHS, RHS equal to RHS, okay? So x equal to t and x equal to 1. Here LHS are equal, then RHS are equal, so t equal to 1. Simple. Now we are putting, since t equal to 1 and t equal to 2, so lower limit is 1, t equal to 1, upper limit is t equal to 2. Now I put this 1 in here, 2i 1 cube by 3 minus this 2 would multiply both sides because it is out of bracket. So this 2 is out of bracket, okay? So this 2 would multiply to both the terms because these terms are separated by minus sign. Minus and plus operations separate terms, while multiplication and division are of same are joining terms, like make the same terms because they are a fraction or they are some number, they are same number. But addition subtraction of variables, it can vary, right? So it doesn't stay the same. If we just add the coefficient, it won't be the same because there is no coefficient in addition subtraction. Then this 2 if 2 is out of bracket, so this 2 will multiply to each term separately, right? Like this 2 and this 2, so 2it cube, and 1 also we put here. No, first we have to put 2 because this is upper limit. I am really sorry, I made a mistake. So here t square, so 2 square into 2, this 2 also get multiplied here, 2 into 2, this is actually then 2 cube, right? This is 2 cube, this 2 is multiplied to this, then this would be 2 raised to 4 actually, 2 raised to 4 by 2. Let's just keep that then. This is t square is 2 square, this 2 get multiplied, okay? This 2 gets multiplied. Now, and now lower limits time, okay? Now lower limit is 1, then I into 1 cube by 3 into 2, by the way, because this 2 multiplies here 2. 2 multiplies here 2 now, minus 2 into 1 square, t square 1 square by 2. 2 gets cancelled. Same number in division. Division makes them opposite. Like if you take from if you take two parts from two parts, then you take the whole thing, so it is 1, and 1 is multiplicative identity. 1 multiplied by anything is 1, so here it is 1. Here also 2 and 2, 2 gets cancelled, 1. Now we find I 2 raised to 4. 2 raised to 4 is 16, by the way. 16i by 3 minus 2 square is 4. 4 into 1 is 4. 4. Now there is wait a second. Oh, sorry. Minus is multiplied into this whole bracket, by the way, because minus of whole, okay, minus of lower limit. So this lower limit whole term would be multiplied by minus. So minus here, there was minus. Because of this, there was minus here. So minus plus would be this would term would still stay negative, but this term would become positive. Okay, this term would become positive. Let me put minus here again. So let me do this. 1 cube into 2 is 2 because 1 cube is 1. So 2i by 3. But here minus into plus stays minus because opposite signs multiplied stays minus. This term would be negative. This term would be positive because minus into minus, same signs get multiplied to give plus. Then this is 2 minus minus gives plus. Okay, same term, same sign multiplied give plus, positive. Now here we have uh wait a second, 2 square, right? Okay, 1 square. Okay, 2 got cut, it became 1. 1 into 1 square, because 1 square is 1, this is 1. 1 into 1 still 1, plus 1. Okay, so this is the answer of integration z square dz. Okay, this is equal to, wait a second, I have to extend this line, this still looks very messy right now. Okay, wait a second, to erase this line. Oh boy, this looks very messy, man. I guess we need Ronaldo 90 right now. So, okay. Now, this is integration z dz. Here we go. Kindly take the screenshot, huh, please. By the way, I have to wait a second. This is so blurry. Yeah, now it is. Yes. So take the screenshot, take notes, whatever you want to take. I had to do the second half too, like y square equal to x, but now I have some things to attend to, and also this device battery is dying, so I have to go for now. Sorry, guys. I may cover that in shorts, or maybe I would come live or something. So if you have any doubt, ask in comments, in chats, like, share, subscribe. Thanks for coming. Welcome to thanks for coming to the stream. Really grateful for your support. You really make my day liven this place up. Okay. Uh, like, share, subscribe. See you next time. Thanks for watching. Peace out. Pachuk, 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 pachuk.